Hi, this is Dr. Goldstein, and I am going to be explaining functions. So a function is an assignment from a set X to a set Y that associates to each element of the domain an element of the codomain. So typically we call our domain X, and we call our codomain Y. And so each little x in X gets assigned an f of X in Y. Okay, so let's look at one example of this. It's a very abstract example. I have here on the right, I'll call this function f. And so this f goes from the set X to the set Y. And my set X is this collection of colored shapes. My set Y is just a collection of colors, and my assignment is assigning to each shape its color. So the red triangle goes to red, the yellow rectangle goes to yellow, the green something shape goes to green, and the red square goes to red. So here is another example of something that you might be a little bit more familiar with. So let's say my function goes from the real numbers to the real numbers, and it is given by the assignment f of x equals x squared. So this is something that is a little bit more typical that you're more likely to actually come across. So here, this is my set x that is my domain, and here I have my set y, which is my codomain. And in this particular example, they're both the same. So for example, if I have little x equal to 3 in my domain R, then f of x, which I denote by f of 3, this is going to be 3 squared, which is 9, and this is an element of my codomain y. So in this case, the element 3 of the domain gets sent to the element 9 of the codomain. So again, if we're looking at our function f going from R to R, for example, 3 gets sent to 9. As another example, if I have x equal to 1, then f of x is f of 1, and 1 squared is 1, so 1 gets sent to 1. And if x is minus 1, and I look at what it gets sent to, f of minus 1 is negative 1 squared, which is also 1. So negative 1 also gets sent to 1. Let's look at two more examples. So my first example here on the left, I am going to call my function g. And again, g goes from the domain x, which in this case is the set 1, 2, and 3, to the set y, which is the set A, B, C, D. So again, here, this x is my domain, and the y is the codomain. So in function notation, what we have going on is that g of 1 is D, g of 2 is C, and g of 3 is also C. So one thing that you'll notice here is that the outputs of my function, the elements of the codomain that I get, are not actually everything. So that is what is called the range of the function. So here the range of this function are just the letters of the codomain that I actually get, and in this case it's just C and D. So a very important observation is that the range and the codomain do not have to be equal to each other. Okay, so on the right-hand side here, I have a non-example. And I am going to call this function h. So again, h goes from x to y, where x is the set 1, 2, 3, 4, and Y is the set A, B, C, D. Now, H is not a function. This assignment here is not a function, and there's two reasons for it. The first reason is that H of 3 is not sent to anything. It's not defined. And also H of 4 is not defined. So I have two elements of my domain that are not assigned an element of my codomain. Another issue with this is if I look at 2, I don't know where it's sent. It's either sent to B or C, and I still don't know which. So these are two things that can go wrong. We say that our function is not well defined because some values are missing, and some values, they might go to two different things. I don't know what they are. So again, our first example is a function. G is a function. H is not a function because it's not well defined. So I want to talk a little bit more about domain and range in a specific context. So a lot of the time you're going to see a function where the domain is not, the domain and the codomain aren't really defined, but it's understood that they're subsets of the real numbers. So if you have a function that's defined on some subsets of the real numbers, we'll talk about the domain first. The domain of your function is going to be any real number x such that f of x is actually defined. So two examples. We'll go back to our familiar f of x equals x squared. If we don't define the domain of this function, I look at this expression and I say, what is that defined for? And I say, well, I can square anything, so it is defined everywhere. I can plug in anything. So the domain of this function, f, is the set of all real numbers. And if you want to write that in interval notation, it's this interval from minus infinity to infinity. On the other hand, if I look at this function g, I remember that you cannot take the square root of a negative number. So if I look at g and I say, well, where is it defined? It's defined for x greater than or equal to 0. So remember, the square root of 0 is just 0. So 0 works fine. It's just negative numbers that don't work. So I say that the domain of my function, I can write this in set notation as x in R such that x is greater than or equal to 0. Or I could write it in interval notation as this interval that starts at 0 and goes off to infinity. So that's the domain of these functions. Again, it's anywhere where the expression is defined. So now let's talk about the range of a function. So the range of a function are elements y that are equal to f of x for some x in the domain. So they are all of the outputs of my function. Now range is typically harder to compute. The way that I like to look at it, the way that we're going to look at it right now is by looking at the graph of the function. So this is the graph of f of x equals x squared. And remember, the domain of this function we decided was all real numbers. So here's my domain. Now the codomain of this function is also all real numbers. That's my target space. I know that I'm mapping into the real numbers, so it's the entire y-axis. But the range is going to be only those y values that I actually get. So from 0, I get all of these y values out of this function f of x equals x squared. If I take an x and I map it to my graph and I look at what's the y value that I get out of that, I'm going to get anything 0 and greater. So the range of this function, f, is this interval that starts at 0 and goes off to infinity. Okay, so let's talk about g, and again I'm going to graph this. So here's my Cartesian plane. Now remember, the domain of this function is only 0 to infinity. This is my domain. Now theoretically, again, I could get any real number out. So here's my codomain, r. But if I actually graph the square root function, this is what it looks like. And it keeps on going up. And so the actual y values that I get out, if I take any x value here, and I map it over here, and I just look at its y value, I'm only going to get positive outputs. So again, here the range of this function, g, is this interval from 0 to infinity. So the function g actually has the same domain and range. The function f has a different domain and range. Okay, so again, range is a more complicated concept because you actually have to figure out what are the outputs of my function, and that depends on what you put into your function. So I like to look at it using graphs, and there's other ways to do it that I'm not going to get into right now. Okay, so that's a quick crash course on functions from the abstract to a little bit more explicit.